We've been taking a look at brackets, and we've been factoring out and looking at multiplying and so on. We're going to take that a little bit further in this video. UK government absolutely love to control things, and this is their actual website, the government website, UK website, all to do with what is taught in GCSE and to a greater extent how it is taught as well. Now look where my arrow is here, and then we're focusing in on, we could be looking at difference of squares as well, but factorizing quadratic expressions of the form ax squared plus bx plus c. This is where the focus is going to be today. The most obvious question: what is a quadratic equation? Well, let me open up. I think the best way of explaining that is pictorially. My graphing package here. In its basic form, its simplest form, which is a good starting point, we have the answer is equal to messing around with or changing some value, unknown value, but the thing is that unknown value is squared. That's it in its basic form. You put a number where x is, you multiply it by itself, and you get your answer. The shape of that is this, where it is an upward opening, like a horseshoe. Whatever value of x we put in, we square it. So if x is 2, where that pointer is, square 2, come up, and we get 4. Now the thing about this is squaring numbers. Negative 2. Well, negative 2 multiplied by negative 2 gives you a positive answer. So that would come up there, and it will also give you the answer of 4. Very important fact. When multiplying or dividing, if the signs are the same, the answer is always positive. Now that is the basic shape. I can turn it upside down simply by saying, let's make the answer negative. So all the y's, whatever value we put into x, we're forcing the answer to be negative. So the horseshoe shape would be the other way up. We have that. There you go. You see, it's exactly the same. If you have positive 2 and you square it, you get 4. But we're saying, no, we don't want positive 4. We want negative 4. So you come down, and there's your answer. That is what that minus sign there does. It turns it up the other way. Now, interestingly, you won't be required to do this. Can you turn it the other way around? Yes, you can. Look, you're not supposed to know this, all right? X equals y squared. And look what happens. All right? You don't need to worry about this because it is not part of GCSE. It's turned it to the side. It's saying x is the answer. So you're messing around with y. All right, look. Come on, behave yourself. The answer. So the shape of the graph is symmetrical about the axis that's used for the answer. So if we change that again back to y equals x squared. Oh, what happened there? The horseshoe shape would be symmetric about the y-axis. There you go. Or if we change it to negative, to be more specific, the shape will be symmetric about the negative part of the y-axis. So we have that. That is it in its basic form. Okay, so what happens when we start to change things? What happens to this picture here? Let me get rid of that. We don't want that now. Delete. It's gone. Okay, we have the basic form y equals x squared. Now if you watch my graphs on straight line, you're going to know what that does. Basically, it lifts the whole thing up by 2. I'll show you what I mean. Look, there's your basic graph. Now, if I put in here y is equal to x squared plus 2, see, this x here has a particular value. This one is saying add 2 to it. So if we add 2 to that, we get this equation here. And it's the red line. Look, look, look. There's the blue line. Right, that's that one. And that's the red line. It's lifted it up too. Look, 1, 2. Exactly the same shape. It's just that it's moved up by 2. And another point worth noting, this value here is where the graph passes through the y-axis. Well, this is true here. Look at this one. Let's look at that one. If I go plus 0, that 0 is where the blue graph crosses the y-axis. It's at the value y is equal to 0. This one here crosses the y-axis at y is equal to 2. Because our x values here, 5, 4, 3, 2, 1, 0. Our x value there is 0 at the y-axis. So at the y-axis, the graph is 2. Passes through the y-axis at y equals 2, and this one here passes through the y-axis at y is equal to 0. Just to prove a point, suppose I was to change that value there. Instead of 2, we put 5. It should pass through that point there. Let's have a look, shall we? Y is equal to x squared plus 5. So we expect the graph to pass through the y-axis at the value of y is equal to 5. And look, there it does. There it does. That is the graph. When x is 0, y is 5. So it goes through there at that point there. Notice at the bottom the bracket 0, 5. Again, I mentioned that in previous videos. The 0 is the value of the x and the 5 is the value of the y. So it's always x, y, like in the alphabet. Same order, w, x, y. So it is x first, then y second. The value of x for the purple is 0 at that point. The value of y at that point is 5. This one here, the red, the value of x at that point is 0, because it's where x is indeed 0, and the value of y at that point is 2. Here, the value of y at that point is 0, the value of x at that point is also 0. They're both 0. Always have x first. X is 0, y second, y is 0. Makes sense? Okay. To reinforce the point, let me clear this lot away, shall we? Delete. It will still leave the labels, so I'll have to delete those. Okay. Now, stressing the point, y equals negative x squared. I'm going to put plus 0. People don't normally write it when there's 0, you know, they don't normally write it, but I'm making a point here. Okay, so this is the graph that I put in where the x part is negative, so it gives a downward shape. Here, look, the bit in the brackets, x first is 0, that's fine. Y second, y is 0. So again, that follows what I said previously, so that's fine. However, why have I done that? However, watch what happens here. Y is equal minus x squared, because those are the ones we're looking at. Suppose I go plus 2. What happens there? Same shape. That's your equation. Oh, come on. Give it to me in a moment. So the red is negative x squared. But plus 2. It's still going through the value of that constant there. It is going through the y-axis at the point where x is 0 and y is 2, positive 2. So it's still going through that value there. And if I put in here y equals negative x squared, so it opens downwards, plus 5. Now that means we would expect the graph to cut the y-axis at y is equal to 5. And let's have a look. And indeed it does. X first, y second. X is 0 because that's where the y-axis is. The y value of that point is 5. So its coordinate is 0, 5. And that tells us it's where my little pointer is. Okay, so that is a little bit of information that you really need to fix in your mind. Do I want to do that? No, I don't want to do that. I want to minimize it. Remember, this part of the video is just to give you a feel of what the quadratic equation is and what it does to values. So let's look again, but this time we're going to change something else. We're going to add a different bit to it. We got y is equal to x squared. That's our basis upon which everything else is built. We've got what we had was plus some constant. I'm going to do 4. That's what we were just looking at. But suppose I were to put in there plus 4x. What does that do? This is part of the structure that the government want you to look at. Oh, by the way, if you want to include it, you put a 1 there. People don't write it, but it's there, right? It is there, they just don't write it. We've got 1 of x squared. We've got 4 of x put with it. And we've got the constant 4. Let's make that a different number, shall we? Let's just make that 3. Now, by what I said before, we'll get rid of that. The graph should cross the y-axis at y equals 3. That's the first thing we need to look at. Will it do that? Let's have a look. There you go. It has indeed gone through the y-axis where x is 0, as you would expect, because that's where the y-axis is, and it's cut through the y-axis at the point y is equal to 3, which matches the equation. Come on. That's the constant. It doesn't change. It's where the graph cuts through the y-axis. But because we put that in there, notice it's no longer symmetrical You know, the y-axis is not in the center. It's shifted 4. If I were to half the value of 4, I would get 2. That's the minimum. It matches at x is equal to -2. Will it show it? Will it show it? It's not. It's playing up. It's not going to do it. Slight variation. Look, x equals -2. Let's make that a dotted line, shall we? Do that. You can see here that is -2. Your minimum there is exactly where x is -2. And its value, we don't need to worry about the y at the moment, you know, the -1. We're just looking at the -2. -2. Half of 4 is 2, but it's gone negative. The 4 here, this is positive, so it's changed that. So we've halved that, and we've reversed that process there. Instead of plus, it becomes negative. Okay, is this always going to be the case? Let's get rid of that. Suppose I were to change that to 5. Now, half of 5 is 2.5. But this is positive. So we would expect, by what I just said, for it to be -2.5. Let's see if it is indeed. If I put y equals -2.5, make that dotted, that is where we would expect to have the minimum value. And I've done that the wrong way. Hang on, that should be x equals. Well, that certainly looks as though it's the axis of symmetry. It's the center of that curve, isn't it? And its value, where they cross, it doesn't show it very well. Hang on a minute, let me lift that up a bit. Look at the first value in the brackets, -5/2. It's shown that we've halved that, and we've changed that to the opposite action. We've changed it to subtract instead of add. So if I were to make that -5, we would expect it to be on the positive side. Let's get rid of this. No. Okay, let's change it to positive. So let's now move that vertical line, look, here. So we would expect this point here, this minimum, to be on that line if I were to make that negative. Will that happen? Let's have a look, shall we? All I'm doing is changing that sign to minus. So we expect the reverse operator, the opposite to that, is plus, and we would expect the minimum value to be half of the 5, which is 2.5 or 2.5. There you go, look. We've got 5/2 as the x value, and it's on the positive side. It is the opposite to that minus, and it is half of that 5. Now this happens if we have 1 there. What happens if we don't have 1 there? Let's put 2, shall we? It's not the same. It has changed it. We can be dealing with that a bit later, all right? Just accept that this here turns up at half of that if the number in front of the squared x is 1. So let's put it back. Change that to 1. And there it is. The minimum point, or the turning point, proper name is vertex, the turning point, when the number in front of the x squared is 1, not normally shown, is half of that value there, and we do the opposite. In this case it's subtract, so the opposite is plus, so we expect the minimum to be at plus 2.5, and indeed it is. This is a quick introduction to how the thing behaves. I'm going to keep the video short, stop here. The next video we will be looking at the equation mathematically.